Hey everybody, welcome to Mabuhay-Mathematics. This video introduces the concept of common factors and is the first in a series of videos I'll release on basic factoring techniques and uses. So if you watch the video and practice along, you should be able to define the term factor, identify common factors, and rewrite expressions using common factors. We're starting off light, so the examples we cover here will only include integer coefficients. So if you have any aversion to decimals or fractions, no need to be afraid here. So, what are factors? First, let's remember what factor means in the context of whole numbers. Suppose a times b equals c. We can say two things right away. C is the product of a and b and b are factors of c. So the result of a multiplication is a product, and the numbers that combined to form the product are factors. This is using factor as a noun. As a verb, to factor c means to write c as a product, so we can factor c as a times b. Consider the number 12. Let's see how many ways we can write 12 as a product of whole numbers. If you have the idea already, you can pause the video and think about it independently for a minute. So how many ways can we rewrite 12 as a product? There's 1 times 12, 2 times 6, 3 times 4, and 2 times 2 times 3. By the way, if you think I missed one, you can go ahead and let me know in the comments. Fun fact, every whole number can be factored as 1 times itself. Since this doesn't really give us any new or different information, we call it the trivial factorization. Additionally, any whole number greater than 1 can be factored as a product of only prime numbers. We call this the prime factorization. This one is a little special because it is unique. For any whole number greater than 1, there's only one way to write it as a product of primes. So, based on these products, the numbers 1, 2, 3, 4, 6, and 12 are all whole number factors of 12. Okay, so let's kick it up a notch. Say we want to write 195 as a product of whole numbers. And let's say that looking at that 5 in the ones place, we know that 5 is a factor. So how do we find the other factor that goes with it? This is a key trick in algebra. We actually pretend that we know the answer. This is one of the reasons we use variables, actually. They act as a stand-in for the unknown answer. So I'm going to pretend that the factor we're looking for is b. I already know it, it's b. Okay, then we apply the definition of factors or products to write 5 times b equals 195. From here, we want to isolate b. So in this case, we can divide both sides by 5. On the right, we get 195 divided by 5, which is 39. So b is 39. And this tells us that 195 factors as 5 times 39. Okay, so this approach of pretending to know the answer and applying the definition allowed us to find a missing factor when we knew one of them. Okay. More generally, if you have a trio of numbers a, b, and c, none of which are 0, and you know that a times b equals c, then we can always write b is equal to c over a. Like I said, as long as none of these things are 0, then we can always write b equals c divided by a. And this is just an extension of that same technique. Great! Now that we're warmed up, let's get into some more algebra. Suppose we want to factor 3x squared minus 18x. If you want to try this one out on your own, you can go ahead and pause the video now. This expression has two terms. First term is 3x squared, second term is negative 18x. First, we're going to identify common factors, which are factors that appear in both terms. Looking at the constants, we see that 3 is a factor of both 3 and 18, so 3 is a common factor. We can also notice that there's at least one factor of x in both terms. So x is also a common factor. We'll combine these common factors together as 3x. Next, we divide the original expression by 3x to find the other factor that goes with it. Okay, so we have 3x squared minus 18x, all divided by 3x. We can split the fraction into two separate terms to get 3x squared over 3x and 18x over 3x. Handling them one at a time, we should get x minus 6. Okay, let me know in the comments if you have any questions about that calculation. But this division now, okay, taking the original, dividing it by 3x to get x minus 6, tells us that we can rewrite the original expression as 3x times the quantity x minus 6. We again used division to find the factor that combines with a known factor, in this case 3x, to get the original. Okay. By the way, there is a reason why I recommend keeping the division stage of factoring with variables as scratch work or mental maths. You can see I have this note here on the second bullet. Rather than being part of your formal solution. Not every teacher is going to care about this, but there is a reason why I make this recommendation, okay? If you know the reason, go ahead and drop it in the comments and share the wealth, okay? As a hint, if x is a certain number, the division actually doesn't make sense. Okay, I'll leave it there for now. We'll get into these kinds of details in future videos, but feel free to open it up in the comments. Okay, so we can say that we factored out 3x from our original, and now we have this factored form of the expression. Great. Now it turns out this process of pulling out a common factor is actually equivalent to the distributive property. Okay, so here's how we usually write the distributive property, right? A times quantity B plus C equals AB plus AC. It tells us how to distribute the A to the other two terms, the two terms inside the parentheses. Okay, and we usually think of this as an expansion process. Okay, but equations work in both directions, meaning we can use the distributive property from right to left instead. So take a look at this equation. This is just the distributive property reflected over the equal sign. Okay, so thinking of it from right to left in the way that we usually write it. In this form, we can see A on the left as a common factor. And what the equation is telling us, what this rule is telling us, is that since A is a common factor, we can pull it out in front of those other factors which are combined together inside the parentheses, those other factors being the B and C. So thinking of the distributive property this way, it's telling us how to rewrite the original expression with the knowledge that A is a common factor. And so what we want to do is compare this to the example we did on the previous slide. So we want to align the A, B, and C with the right pieces from the last example. So what we're going to do is let 3x be represented by A. Say A represents 3x, B represents x, and C represents negative 6. Okay, and now we're going to make these substitutions into this reflected version of the distributive property. So we have to think, what's A times B? That's going to be 3x times x. 3x times x is 3x squared. What's A times C? AC is going to be 3x times negative 6, which gives us minus 18x, and that's the left side, AB plus AC. On the other side, we have A isolated outside of the parentheses. Okay, A is 3x. And then inside of the parentheses, we have B plus C. B plus C in this case becomes x minus 6. And so, having these pieces identified, the distributive property tells us exactly how to rewrite our original expression in the factored form. Okay, once we've identified the common factors, in this case the 3x, and technically we also need to identify what's left over when we take out the common factors. That is, we need to use division still to come up with the x minus 6. But once we have all those pieces, distributive property tells us how to arrange them appropriately. All right, everybody. Now that we have a better idea about the terminology and how factoring works, let's do some exercises. Okay, so identify not necessarily the greatest common factor, so I'm just going to say identify a convenient common factor in each expression, and write an equivalent expression in factored form. Okay. Even if you're not completely confident, if you feel like you understood the technique so far, you can go ahead and pause the video and try this out on your own. It's even okay if you try to make a mistake. It turns out that if you try something and you make a mistake doing it, but you go back and understand why it's a mistake and how to do it correctly, you'll actually learn it better than if someone just shows you how to do it right the first time. So that said, I'm going to go ahead and go through this. So in part A, we see 9x plus 3. Looking at the constants, the 9 and the 3, there's a common factor of 3. And since only the first term has an x, not the second term, x is not going to be a common factor. So the common factor is 3. So we can rewrite 9x plus 3 using division as 3 times the quantity 3x plus 1. The 3x is coming from 9x divided by 3, and the plus 1 is coming from 3 divided by 3. Remember, taking each of the original terms and dividing by the common factor. Great, and then the other thing to point out here is that if you need to check, or if you want to check yourself, then all you need to do is redistribute the 3 into the 3x plus 1. That is, multiply 3 times 3x. Hey, look, that gives us 9x. Multiply the 3 by plus 1. Hey, look, that gives us plus 3. And so these are very straightforward to check, so you can always know whether you've done it correctly or not. Okay, part B, negative 12t minus 16. I'll point out right away, we don't see t appearing in both terms, only the first one, so t is not a common factor. Looking at the 12 and the 16, 4 is a common factor of those two numbers. And so we know 4 is a common factor. In fact, it's the greatest common factor, but it might not be the most convenient, because in this case, we also see both terms have a minus sign in front. Both terms have a negative coefficient. And so it's typically convenient to take the negative 1 out with the 4. And so to identify negative 4 as the common factor, when we do that, we are left with, in the second factor, we're left with the quantity 3t plus 4. Okay, 3t is coming from negative 12t divided by negative 4. And plus 4 is coming from negative 16 divided by negative 4. And then part C, we have 28b squared minus 14b plus 49. Again, we see the variable in some of the terms, but not all of the terms. We see the variable in the first two terms. We don't see that same variable b in the last term. And so b is not a common factor, so we're just left to look at the coefficients. I see a 28, a negative 14, and a plus 49, and turns out that all of those numbers have a factor of 7. And so the common factor that we'd like to pull out of this is 7. When we do that, we're left with the quantity 4b squared minus 2b plus 7. All right, I want to point out one more thing here. When we write this equation at the end, it is analogous to writing an answer in another class, like a writing class or a history class. It's analogous to writing your response in a complete sentence. Equations are complete sentences. And so this is on the upper end of formal when we're told to factor. Okay, sometimes you'll only need the two factors that you got, the factored form, but it's important to understand that when we factor, we're coming up with an equivalent expression. And so if we factored correctly, it should indeed be equal to the original. And so even if you don't always have to write your answer in a complete sentence, that is, write your answer as a factoring statement, it's important to understand that it is true that these are equal. That's the point of what we're doing, is coming up with something that's equal to the original. but a different form. Okay, let's move on. 3 more, same idea. Okay, if you're feeling good about this, or at least feeling adventurous, go ahead and pause it now and try these on your own. Okay, part D, 12x squared y minus 42xy squared. So looking at the constants, we see 12 and negative 42. Both of those have a factor of 6. Looking at the variables, we see both terms contain at least one x and at least one y. So x and y are both going to be common factors. To figure out what exponent you should include with those common factors, the rule of thumb, the trick, is that you want to grab the variable to the least exponent that you see in any of the terms. So let's focus in on x. I see x squared, so x to the second power, and I see x, which is x to the first. So between x to the second and x to the first, the lesser exponent on those two is 1, is the first power. And so we're going to identify x to the first as the common factor. There's only one x in common. Okay, similarly for y. The first term has y to the first, the second term has y to the second, and between the two exponents 1 and 2, 1 is less. And so we'll take y to the first as a common factor. So altogether, common factor here that we want to pull out is 6 times x times y. Okay, now we'll divide both of the original terms by 6xy to find out what's left over. And we should get the factored form as 6xy times the quantity 2x minus 7y. Again, you can redistribute, you can distribute the 6xy into both the 2x and the negative 7y to check this, and you should be able to verify that we get back the original expression. Okay, part E, 21t to the 6th plus 35t to the 4th minus 14t cubed. Looking at the constants, the coefficients, 21, 35, and 14, negative 14, there's a common factor of 7. And then looking at all three terms, there's a common factor of t, and what we want to do again is grab t to the least power that we see. So I see t to the 6th, t to the 4th, and t cubed. And so among those exponents, 6, 4, and 3, the least exponent is 3. So the common factor will be t cubed. That goes along with the 7 to give us 7t cubed. Pulling out that 7t cubed gives us quantity 3t cubed plus 5t squared minus 2. Again, we get all of those terms using division. So you divide each of the original terms by 7t cubed, and then we use the distributive property to tell us how to arrange everything in the factored form. Okay, last one. This one is a little trickier, and so I wanted to try to be a little helpful and put this thing u minus 1 in parentheses, even when we don't need the parentheses. And the reason is because we want to train ourselves to identify u minus 1 in this case as a common factor. So we sort of want to look at this as just being a two-term expression. The first term is 2u times quantity u minus 1. And the second term is the quantity u minus 1. And if we think about it that way, we can identify u minus 1 as its own factor, and indeed a common factor. So we factor out the u minus 1 from both terms. In the first term, all that's left is 2 times u, okay, because those are the other factors that were multiplied by u minus 1. Okay, in the second term, we only see plus 1 because u minus 1 divided by u minus 1 is just 1. And so, factored form, we get the quantity u minus 1 times the quantity 2u plus 1. And again, you can distribute u minus 1 to the 2u and the plus 1 to get back our original. Okay, great work, everybody. Let's just take a recap of what we covered in the video. So we found out that if A times B equals C, then A and B are factors of C, and C is the product of A and B. Factors form products, and products are formed by factors. It's this relationship between factors and products. Common factors are factors that appear in each term of an expression. The distributive property tells us how to handle common factors, and in fact, there's an equivalence between factoring and the distributive property. And last but certainly not least, factoring is a division process. Every time you're doing a factoring problem, whether you're factoring a whole number or factoring algebraic expressions, you are performing division. And so the more explicitly you emphasize that division, the faster your factoring work will become. Thanks, everybody. Thanks for watching. Don't forget to like and subscribe. Let me know if you have other questions in the comments. And also feel free to let me know if there are other topics you'd like to see covered. Okay. Thanks again, everybody. Take care. I'll see you next time.